Before you actually build in the motherboard into the case, it's always a good idea to put in this I/O shield first, and that is because often people simply forget to put the shield in, just slap it in there first, and I can tell you most of the time these I/O shields, they are larger than the hole cut, so you need to push them with force. Don't worry about it, it's just a sheet of metal, it will bend just fine, push them in and they're gonna stay in there, no problem. Then regarding the motherboard installation, now that might be a little trickier for people who are not putting together several PCs, and one of the big gotchas is that you have to use these small standoffs. I need to zoom in, so let me change the lens. So the functionality of these standoffs is to keep a space between your motherboard and the case itself, because otherwise your motherboard would be short-circuited. That's no good. So you always need to install these standoffs. You have several different types. This one is a better type because they are hex nuts which you can nicely screw in and out. There are other types which are a lot more fiddly. Luckily, the Fractal design case is doing a good job from this perspective. The standoffs are in very special locations. Okay, so they are supposed to be according to the EATX standard, and there is one golden rule which you definitely always need to respect when you build together a PC, that you should have no more standoffs than how many holes you have in your motherboard for screws. Because if you have just one more standoff somewhere, you know, which you could screw in, I don't know, like there as an example, there is a hole what you could screw in an extra screw, that would totally short-circuit your board. So always count the number of standoffs you put into the case and count the number of holes which are in your motherboard. I will explain what I mean in a moment. And they have to match. If you have more standoffs than holes, that's no good. You should remove the motherboard before you turn that thing on. After I put in the motherboard, then I have always the hole on the motherboard matching with one of these underlying copper spacers. And this is something what you need to take care. That is what I meant, that you need to count the number of holes and you have to put in just as many spacers, definitely not more. Even if you put in less, that is better than putting in more spacers than how much you need. Because let us suppose that here as an example, there is, I can tell you, there is a hole on the case itself, because there are some type of motherboards which do have a hole here, and by mistake you could screw in one of these copper spacers here, okay? Then you put on top of that your motherboard, you just not gonna see it anymore, you don't notice, and since you haven't counted the number of holes and the number of spacers, now you have one spacer which is totally short-circuiting your board. So here I have already the motherboard put inside the case. It is not screwed in yet, it's just that at this stage I'm checking whether really all the holes are being properly aligned with the underlying spacers. To find where to put these spacers, as an easy trick, you can remove first of all the spacers. You can then take a thin Sharpie, put the motherboard just into the case, align it of course with the I/O shield, the different type of connectors, and then with your Sharpie just make marks on your case. I mean in this one, yeah, don't use a black Sharpie. Anyway, so if you do that on each hole, after you remove now then the motherboard, you're gonna have nice Sharpie markings of where to actually put in these spacers. And I can tell you, when I was really younger and I just started making PCs and putting them together, that trick really helped me out a lot of times. So yeah, you might just use it as well. Because the I/O shield is pushing back on the motherboard, then I found that it's always a good idea to push with your fingers against it. With your other hand, of course, you are holding the screwdriver and the screw. Hopefully you have a magnetic screwdriver. You just push against this spring here, and once it is aligned, you drop in the screw and you put the screw halfway in. Don't screw it in all the way, because you're gonna see that the other holes are actually not fully aligned. So we're gonna need to play the same game. So as an example, as you see, I have to push with my thumb on it, and it will be automatically moving back because of this spring force here. And yeah, we're gonna do this through the whole motherboard, just screwing in the screws halfway. And once all the screws are halfway in, then we're gonna go all over them and screw them nicely, and yeah, not crazy tight, but just tight. So once the motherboard screws are all nicely screwed in, then you just plug in the 8-pin power here. Then of course the 20-pin standard EATX. Now on this part, where you have to plug in the different cables, which are like the power switch, the reset switch, the power LED. And in my case, as I mentioned, I modded the case, so I added an LED. This is why it looks a bit more wacky. Actually, this is where you can see that I used heat shrink tubing on the cables. I personally want to have a clear feedback when I'm reading or writing from, especially when I'm writing to the hard disk. This is why I put in this extra LED. And yeah, anyway, whenever you are putting this thing together here, you have to look into your motherboard, because they give you the pinout. I don't know whether you can see it here. Actually, Gigabyte does print most of the time the pinout next to these connectors here. I mean, they are really tiny letters. One can barely see it. And that helps to line them up. Or Asus even often gives you like a small breakout connector here, where you can install these small connectors, the switch connectors on this breakout, and then just put in the breakout once you are done. I find that actually really practical. I don't know why Gigabyte is not doing the same thing, because often it saves you. This is the USB 2.0 connector here, which is going to the front. And then this is the USB 3.0, which is then going to the two USB 3 ports also in the front panel. Next I'm gonna install then this PCI Express video card here. It's passively cooled and it doesn't need any extra power connector, that's why I like it. So this will be used to install the base system, because I wanna have a relatively decent video output when I need to work with the virtualization host directly. And once the software installation is mostly done and I can log into this box over SSH and use just the command line, then I will actually exchange this thing in order to save one of the PCI Express ports, and I will use one of these old S3 Trio old school 32-bit PCI video cards, just to get some very minimal video output if I need to debug the virtualization host if it doesn't boot or something. Actually, strictly speaking, for only bench testing, these cards did work. However, the newer motherboards have such a BIOS that most of the time they are trying to initialize first a PCI Express video card, And if they don't find a PCI Express video card, they might never initialize video, and you might think that there is something messed up in the system. So this is why I prefer to use for testing these cheaper PCI Express cards, then set up the BIOS such that if you have this option to set the so-called init display first, to set it to PCI and not PCI Express. Because then you can be more sure that your PCI video card is actually being initialized. Now regarding this video card exchange and this whole hustle around with the two video cards, so this is the PCI Express one, which is then of course occupying a PCI Express port. And with this one is that if this motherboard would be some server grade motherboard, then most probably you would have IPMI built into the motherboard, which means that you can just plug in a network cable into the motherboard and have the video output send over IP. Well, I mean, such motherboards would be a lot more expensive. This is why I stick with this El Cheapo version of just PC components, which means that we don't have the luxury of a built-in like Matrox video card, because IPMI mostly uses Matrox. And also we don't have an IPMI chip, which means that I cannot remotely restart or do any maintenance on this machine if I don't have direct physical access to it, or if the OS is not booting until, you know, the being able to start an SSH shell or FTP or SFTP or anything like on it, because there is just simply no way to get into the box. So this is one disadvantage of using a personal computer grade motherboard. After I now install this video card, then I'm gonna do a bench test of this system. And it's important to point out that when you are doing the first power-up test, you do not attach any of the hard disks to the system, because if there is any type of failure, you never know. You might have made a mistake, the motherboard might be wrong from the very beginning, who knows. You're gonna mess up also your disks, and you might mess up for sure also your data on the disk. So just for a power on self-test, just power it on and see whether you can get to the BIOS. So I have tested the whole thing on my Dell monitor. Luckily it boots up. I got into the BIOS, things are looking fine. And that means that now we can then proceed with the rest of the build, which means that now I will then build in 3 of these quad gigabit network cards, and then we're gonna build the side panel in with the fan put on the side panel. Let's go. So the 3 network cards are these HP NC364T, and these are supported even in ESXi version 6 update 1 and update 2, at least according to the hardware compatibility list. As I said, personally I'm not that much interested for the time being in ESXi. However, of course, this works just fine on the standard Linux kernel, so it works awesome with Linux KVM. And also I tested it and they work just fine also with the VTD, so you can really bypass the cards and give them directly to one of your virtual machines, which is an awesome feature. Now these network cards are electronically PCI Express times 4, meaning that they are, you know, like using only a short part of the PCI Express times 16 slot. And they work just fine in PCI Express times 16 or electronical PCI Express times 16, especially in this Gigabyte motherboard. Actually, if I would be able to zoom in, I cannot really with this camera because it needs an insane amount of light for zoom. So one could see that this port here is electronically PCI-X times 4, even though the mechanical form factor is times 16. This is PCI Express times 8. And this is an old school 32-bit legacy PCI port. For virtualization, we cannot really take advantage of this. I'm gonna use it, as I mentioned, for PCI video card, just to save the slot. This one, after I install the machine, to get a free slot for a InfiniBand card or a host-bus adapter for being able to play with ZFS derived from Sun Solaris ZFS. Actually, I found that I could use also the built-in SATA ports to play around with ZFS. I might just do that and save the money from a host bus adapter. Technically speaking, these SATA ports should work just fine. We will see in the long run. So then let me explain what I did. So I left, of course, this PCI Express times 1 slot empty because I don't have any card which would fit in there. Then next to it there is the first PCI Express times 16, which is also electronically PCI Express times 16. This, for the time being, is taken up by this PCI Express video card. It's a GeForce GTX 8500. It's a really old card. However, for my purpose, for the time being, is just fine because it provides 2560 times 1600 video output through the DVI, which is good for my 30-inch Dell. That I will use until I install the system. Then I will remove it. So the next slot is left empty because this card actually dissipates quite a lot of heat. It uses about close to 40 watt of power, which means that it is getting toasty. I mean it. Once I tried to touch it in my old PC. I touched it when it was working fine, and it literally burns your finger, so you nearly get a blister from it. Now, this is why I left then this slot empty, so at least some of the heat can rise, because this is a passively cooled card, and I don't want to have many fans in this thing because it's just noisy. Then I have 3 of these quad gigabit port network cards built into the PCI Express slots, and these are also dissipating about 10 watt of heat, even 12, which is actually a lot. You would be surprised how hot these things are getting, and especially in the server equipment you don't care much because there is lots of air being forced through the case. In this setup, of course, because I'm going for low noise, and that's why I need to then build here a fan into the side panel, which is then gonna blow air directly into these cards. Otherwise they would be just on fire, literally. I mean, they are insanely hot even when they are cooled properly. As you see, there is only this old school 32-bit PCI port is free, which is not very useful for virtualization. And this is why I need to then free up these 2 other slots later, because I need more functionality from this machine. In addition to VMware ESXi, of course these cards also support the GNS3, where I will be binding the router ports into these Ethernet ports, and then I can really connect to these Ethernet ports with switches, just like I would be connecting these switches to rear routers. Regarding the throughput, that you're not gonna really be able to have the throughput of a Cisco switch. That's not the idea. I have to emphasize that. This is just purely for learning purposes only. Based on GNS3, you cannot build a functional router or firewall or anything like that using the Cisco IOS. One more advantage to this case, in addition to this noise dampening and such, is that it takes a full extended ATX size motherboard, which means that if you are later switching over to a more server grade type motherboard, then you are in luck because you can put it in as long as it fits the extended ATX standard. There are now here 9 of these slots, which means that if you have 9 of these slots in an extended ATX motherboard, then you will have enough leverage now to put them in. So as an example here now, I will use this 9th slot to put in then the RS-232 or native serial port, the DB9 connector, and it has already the right connector at the end. I got this thing from an old Pentium 2 PC which was thrown out. I just took the poor thing and yeah, so that's how I got the bracket. You can still buy these on eBay. And I will be using this native serial port to communicate with my Cisco routers and switches, because I found that the USB to serial converters often have some hiccups, especially when it comes to signaling levels. So because there are 9 slots here, even after we screw in now this bracket for the serial port, I will later still be able to use this old school 32-bit PCI port to put in a really old video card just for debugging once I'm done with the full installation. Then coming back to the serial. So yeah, luckily the port what they use in the motherboard is still the old standard COM port. I don't know whether one can see it on the camera. So, and the pinout, I found you don't need to change anything on the pinout, at least it worked out of the box. So we just plug it in and there she goes. Now we should have a working serial port, which gonna come really handy when I'm working on some of my Cisco equipment. Since I have removed the drive cages which are normally located here in order to have more air going into the case, it means that now I don't really have really dedicated space where to install the hard disks or SSDs. It might happen in the future that I build into the lower half one of these hard disk retention brackets. This is why for the time being I will use this smaller, how much is it, 128 GB SanDisk SSD. This will be the system disk, and then they will be just flapping in the breeze for until I'm fully done with the installation, like this crucial SSD here. And this will be holding the KVM images for the virtual machines. Well, having those SSDs just flapping in the breeze was looking too dodgy. So instead I was just pulling then the power and the SATA cable through these rubber grommets, which are a nice feature of the case, good for cable organization. But anyway, in this case I'm gonna use then the back side of the case to install one of the SSDs. Yeah, I mean there is plenty of space to install it. And then I'm just using this double-sided sticky tape, and then I will tape the disk over the side. I mean, these are not really generating any heat, so there should be no heat-related issue with these. It's just more like a cosmetic thing. So then here is the SSD for the virtual machines taped. I checked, it's pretty, tough on there. It's not going anywhere. I mean, of course, when this will be hot, it might be that this glue gonna let loose the disk. But there is not much space between the side panel and the disk itself, so this will be held by the side panel in any case. It will be definitely better than as it was earlier. Now, one issue is that I simply cannot find any flat surface area where I could sticky tape the system disk. At least not in the back side, even if I rotate this disk. Well, at the end, as you see, I decided to zip tie it instead here next to the other SSD, which I did manage to double side tape, so now it is a real professional solution. So then regarding the cable management, I could have definitely done a better job than this. This ugly yellow SATA cable is on purpose, so I know it is going to the DVD drive. So on the corner then we have the plus 12 volt extended ATX power. Then we have the standard 20 pin ATX power cord. And with the rest of the cable management I didn't do much because, as I said, I will most probably replace this Be Quiet. Once I have time and a little bit of money, I will buy a passive unit or semi-passive unit where actually I have the option of which cables I plug into the power supply. Because now most of these PCI Express GPU is not used at all, but they are still taking up space. I mean, right now I don't care, but if I wanna build in like an InfiniBand card, a host bus adapter with multiple hard drives, then I would need more physical space. So then here is the finished virtualization host. So then we just have the peripherals which we come with the motherboard. Most of the USBs we will not be able to use to pass over to virtual machines because that's how the chipset is laid out. So in the future I will have to buy a PCI Express board which fits into the short PCI Express ×1 port right here, and that should be then a USB card somehow which I can then pass to my virtual machines directly. Then next we have this PCI Express video card which is just temporarily in, and then it will be replaced with a cheapo 32-bit PCI card which will then come to this port here. So I can free up one of the PCI Express slots, and actually two of them, because now this slot is not being used because of the heat what this card generates. Then we have 12 gigabit ports, which will be used then for GNS3, and also they will be used for Linux KVM virtual machines, or you could use them for ESXi virtual machines as well. Here is then a very old school RS232 serial port, which I'm gonna really be using a lot. So now here it is running, and I can tell you that it is really quiet. Most of the noise is coming out, of course, as expected here from this side panel. The rest of it is, I mean, I'm very pleased. You could, technically speaking, you could sit next to this machine and fall asleep. Seriously, it's not making much noise at all. Of course, now it is running idle. I would suspect when I really gonna stress the CPU, then it's gonna crank up. Right now this is just a cable fail. This is just for quickly testing it, how much noise does it make. yeah, so I'm pleased so far, and we're gonna see how does it work in the future. And yeah, that's it from the perspective of the hardware. Thanks for watching. I hope you have learned something from me, the Donkey.